Okay, we're back now. We switched the 1K resistors to 10K resistors on the input of the diff amp. Now I'm connecting the mini grabber to the input resistor. That's on the positive side of the diff amp. Connect that up to the hairdryer resistor. And then connect another alligator clip up to the fixed bridge resistor. And then connect that to the negative input. Then we could turn on our amplifier, turn on our power supply over here. And first thing I might want to do is get out the multimeter, make sure nothing's saturating. I could connect one lead of the multimeter to ground, go to the output of the diff amp, sitting at 3.5 volts, not too bad. So our calculation initially said with the 220K gain that we'd be off by 10.1 volts, and with the gain of 22, we're off by 1.05. We're not too far off. We estimated we'd be off by 1 volt, and we are. At zero conditions, it should be 2 volts, or 2.5 volts, because that's 1/2 of the rail voltage. So we could check that by connecting these leads together, just to see if it works. And we should get approximately 2.5 volts. It's analog electronics, it's never perfect. It's pretty good though, 2.51 volts. Now connect back to our bridge. Let me see if I can do this properly. I think the insulated one went here. Non-insulated one went there. Check our voltage. Put the black wire to the ground. 3.53. So pretty good. So our math worked out. Our bridge is working now. So now it's time to connect it to the oscilloscope. Go to a different camera angle. I guess there's one other thing we could do. We could just check the output voltage on the differentiator. That's pretty close to 2.5. And it's decreasing a little bit. So that might actually get to 2.5. The output voltage of the rail splitter is 2.52. So that's really our zero. Like when there's no signal, this should be sitting at 2.52. It's getting there. And that's because this capacitor is decaying slowly down to 2.52.